So what have we done so far in this AC chapter? Right. So let me give a quick recap so that you guys can. Okay. So first we studied about the AC generator, right? We saw that how from changing to the flux was PA and cos omega t, and then we changed the flux, right? And then it generated the EMF, which was E naught sine omega t. So this was the EMF generated from the AC generator, right? Where this E naught was peak voltage. This E was instantaneous EMF, and this omega was angular velocity. And then we made the graph of this behavior. This was uh, this was 0, then this was pi by 2, then this was pi, and then this was 3 pi by 2, and then this was 2 pi. Right. So this total time was t. This was t by 2, and then this was t by 2. Right. And this point was the peak voltage. So this we did, and then what we did, and then we calculated the average EMF in full cycle. So what did we find when we calculated the average EMF in full cycle? What was that, guys? Do you remember? Yeah. So when we calculated this average EMF, what did we find there, guys? You guys have got it. So we calculated after a big calculation, we found out that it was zero, right. So we calculated the average using this identity. So from 0 to t e dt by t. And when we calculated this, right, so average of sine omega t, we found out that it would be 0. So this whole term became a 0, right. And similarly, we also calculated the average EMF in half cycle. So any of you guys remember this? What was this value? Arsha and Mariam, do you guys remember? Already forgotten. So, yeah, 2 E naught, yes, yes, very good. So 2 E naught by 5. This was the average EMF in half cycle. Now, what is the counterpart of the DC current, right? So let's say if we have this DC circuit and this is the resistance. So what is the counterpart of this DC voltage? Because this is a fixed voltage. So what is the counterpart of this voltage? So this we found out that this was VRM. In AC supply, RMS is the counterpart of DC supply. So this we understood, right? And then what did we calculate? Then we calculated the ERMS or VRMS. And this we found out what? The root mean square EMF, right? So EMF square, mean, and this we found out that this is E naught by. So this is the RMS value that we found. And then we understood about the phasor diagram. So then we understood that what is a phasor. So phasor which behaves like a sine function, right? And we draw the phasor diagram of AC supply. So this, let's say we have this clock and we have, so I gave an example of the second. So you have this clock and the second needle. The second needle is right like this. So it is changing the angle. So this is a rotating needle, right? Second dial or second. So this is exactly the same thing in here, right? So we had an AC supply, and this was the peak voltage. So this length or this vector correspond to this peak voltage, the magnitude of this vector, and the angle was this omega t. So similar to this rotating vector, you have this rotating vector. Let's say this one, let's say this one, and this one, and this one. So this is just a geometrical representation of this AC supply, right? And when you drop down this vector, right? So we already know that resolution of vectors. We have this vector whose magnitude is r, and this is theta. So this part is called the vertical part, and this is r sine theta. So we have this E naught, and when we drop this vector to the y-axis, so this would give us E naught sine omega t, right? So this will give the instantaneous AC supply, and this was the angle. So this we understood, right? And after that, we did a resistive circuit. So in resistive circuit, what did we find? So we had this AC supply and we have this resistance. This is E naught sine omega t. So this is the voltage that we are supplying. But we are finding out that this is the resistance, and we found out that current is also I naught sine omega t. So behavior is same, right? But this I naught value is E naught by R, right? So this is smaller than this E naught. So then we made the phasor diagram of this circuit. So this had the same phase as, so this was E naught and omega t, and then the other current which is with the same phase, but this is I naught. And the angle is again omega t. So phase difference was 0 in case of this resistive circuit, right? And second thing, we calculated the power factor, which was defined like cos phi. So this was cos 0, which was 1. And then the third thing we calculated was average power, which is represented by P bracket. And this we found out that this is VRMS, IRMS, and the power factor. So then we found out that this is VRMS, IRMS, and this cos phi is 1. So this was the average power in the resistive supply. And then we also draw the graph of this one. So which was what? So this was our E naught. So this was E naught sine omega t, right? And this is E naught. This is pi by 2. This is pi. This is 3 pi by 2, and then this is 2 pi. And then we drew, this is minus 0. And then we drew the current that graph. So current had the maximum value, which was I naught. So it will go from minus I naught to I naught. So it will reach here, maximum, then go 0, then reach here, and then this way. So this was I naught sine omega t. This we did in the resistive circuit. And then we did this inductive circuit. So because Mariam was not here, so that is why I am explaining these things again. And if you face any doubt, if you have any doubt, please ask, right? So in the inductive medium, what did we have? We have this inductor. In place of this resistor, we have this inductor whose self-inductance is L. And this is the AC supply. And we solved that voltage was, EMF was LdI by dt. And then we solved this one, and we found out that I was minus of cos omega t, which was sine of omega t minus pi by 2. And we had some I naught here. So this I naught was how much? Aisha, what was this I naught? Do you remember? Yes. What was this I naught, Aisha? Yes, Aisha, do you remember what was this I naught? You remember that in resistive circuit, I is V naught or I is V by R, right? So in inductive circuit, this would be the same, only that you will have V naught by XL. So uh, this is the counterpart of the resistance. So this will oppose the flow of the current. And we found out that this XL is omega L. Right. So this was called the inductive reactance. Okay. So now then we were doing this phasor diagram. So you guys can see that, let's say this is my E naught, right? And when I drop down this E naught, so this is E naught sine of omega t. Now you can see that this current is lagging behind 90 degrees. So in inductive circuit, current is lagging behind 90 degrees. So this was the result of this phasor diagram. So we have to make a 90-degree lag. So in here, this is the current. Okay. And this is I naught, and this is omega t, right? And this is uh, so when we drop down this, so this is I, which is I naught sine omega t minus pi by 2. So this was the I naught, right? And then we also drew the phasor, the graph of these ones. So E naught is this, right? This is voltage or EMF, and current was how much? So current was going like this. So, oh, E naught by, oh, you already told me the answer. Yeah, E naught by XL. Yeah, omega. Yes, yes, correct, correct, Raj. Okay, so you wrote in the chat. Okay. And this I was, the graph of I was, this was minus of I naught cos omega t, right? So we know that this is E naught, right? And we know that the graph of cos is this one. So let's say that this is our I naught, right? And minus of I naught. And in, so let's say this is pi by 2, this is pi, this is 3 pi by 2, and then this is 2 pi. So minus I naught cos omega t. So if t is 0, then this is minus 1. So it is starting from here, then it will reach here, and then it will go in here, right? So in here it will be maximum, and then it will come again, and then it will reach in here. So this was the graph, right? So this was the graph that we did. And lastly, we were doing this capacitive circuit. So this was the last thing that we were doing, right? So okay, uh, where was that? Did I complete this capacitive? Oh, so I just started the which class? Oh, so this we did, and then we were doing this capacitive circuit. So we completed this capacitive circuit, and we found out that this was the current, right? So Aisha and Maria, current is lagging or leading in this expression. So the expression of EMF, okay, yeah. So the expression of EMF is this. So can you guys tell me that current is lagging or leading by pi by 2? Aisha and Maria. Yes, guys,
Yes, sir.
leading, right? So Mariam is saying that current is leading. Aisha, what is your answer?
Reading.
Leading, right? Correct. One. So now we will draw the phasor diagram, right? So phasor diagram. Aisha, in the previous class, did you note down this part?
Yes, sir.
Then we'll do this phasor diagram. Right. So first we make the phasor diagram of the supplied EMF. So that would be angle is omega t. This is E naught. So this would be E naught sine omega t. Right, guys? Now, as we can see that the phase difference is pi by 2 and current is ahead. So if this is the voltage, then current is ahead, right? And this angle is how much? 90. So this is your I, right? And remember, this is very crucial that for the resistive circuit, I naught is V naught by R. For the inductive circuit, I naught is V naught by XL. And for the capacitive circuit, I naught is V naught by XC. So these are the things which are very important, right? I can also write it as VR, VI, and these are the things that we should remember. XL is omega L, and XC is 1 by omega. So these things that we have to keep in mind. Okay, so this is the I naught. And when I drop down to this y-axis, so this would give me I naught sine omega t plus pi by 2. Right. So this is the phasor diagram. Any doubt in phasor diagram? Aisha and Mariam, any doubt?
No.
Okay. So I will also draw the graph and then you guys can. So remember, I is I naught cos omega t. So in this way we can draw the graph. E is E naught sine omega t, I is I naught cos omega t. Right. So whenever we are drawing the graph, so what do we do? So we first, so this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Right. So we know that E is E naught sine omega t. Right. So sine 0 is 0, so this would be in here. At 90, sine 90 is 1, so this would be E naught. This is my E naught and this is my minus. So at 90, this is going maximum, and then it is becoming 0 at pi, and then at this value, it is going minimum, and then it is going. So this is the graph of E naught sine omega t, right? Okay. Now we have to make the diagram of I, which is I naught cos omega t, right? So we know that I naught is smaller than E naught, so let us write this as. So this is my minus I naught, and this is my I. So can you guys tell me if I take omega t to be 0, this is omega t. If my omega t is 0, what is my I? What is my I if cos omega t is 0? So cos 0. How much is cos 0, guys?
1.
1. So this is 1, right? So at omega t equal to 0. So I would be I naught, right? So this is this point, I naught. And at omega t equal to pi by 2, 90, cos 90 is 0. So this will reach here. This is 0, right? So this is the 0 point. And at pi value, cos is minus 1. So at omega t equal to pi, I would be how much? Yes, at pi, how much would be I? This is I naught cos pi. So cos pi is how much, guys?
One.
Cos pi is minus 1, right? Second quadrant. In second quadrant, cos is negative. So minus 1. This will reach here. And then at 3 pi by 2, it will be 0. And then at 2 pi, it will be nine. This would be the graph of, this is the graph of I naught cos, right? Or you can also write it as I naught sine omega t plus pi by 2. So any doubt in the graph, guys?
No, sir.
Okay, so you guys please note down this part, right? The phasor diagram and this one, and then we write all the other things of this uh, capacitive circuit. Please note it down, guys, and then we do the other. Whenever you guys want me to scroll down the screen, guys,
Sir, can you please scroll down?
Whenever you have guys have completed, please
Thank you.
done. Aisha, what about you? So, what are the things that? So, what are the conclusions that we made from these? Right. So, first thing is that the current is leading voltage by pi by 2, right? And then the phase difference pi is how much? Pi by 2. And then the power factor is phase difference pi is pi. Power factor which is cos pi. So this is cos pi by 2. This is, and then we have this average power, which is the average. So this is V RMS, I RMS, and cos of pi. This is zero, so then this would be zero, right? So in this a capacitive supply or in the inductive supply, inductive circuit. In both the cases, average power is zero. So then these are called wattless current, right? So then these are called wattless current. And the other thing that we concluded that this is inductive, uh, this is capacitive reactance, and this is 1 over 2 plus, right? So if frequency is large, this omega is angular frequency or voltage. So if this frequency is large, then this capacitive reactance would be small, which means that this resistance would be small, right? So if these are oscillating, then this reactance would be small, right? And in the case of the inductive circuit, we saw that this was this inductive reactance was directly proportional to the frequency. So this omega tells you about the behavior of the EMF supply, right? Because E is E naught sine of omega t. So this omega t is in here, right? So if your frequency is large, then resistance in the inductive circuit would be large. But in the capacitive circuit, that would be small. So these are the things that. Okay, you guys, please note down this part. And then we will revise some vector portion, and then I will do this LCR circuit. So that circuit is very important. If please, you guys, whenever you guys have noted it down, please.
Done.
Done. And Aisha, what about you?
Done, sir.
Good. So now, before we do this LCR circuit, right? The next topic, which is very important, and this is LCR. So we have this inductor, we have this capacitor, and we have this resistor. So all these things are there in the same circuit. And because in the previous cases, we were studying about only one case. So one capacitive circuit, one inductive circuit, and one resistive circuit. But now we have all these circuits together. So then what would be the current, right? So we will discuss about those, but let us recall that let's say you have a vector which is this, right? This is a vector, and you have this vector which is b vector, right? So what would be the resultant of these two vectors? Yes, guys, can you tell me what would be the resultant of these two vectors? Okay, let me simplify this question. So you have, let's say this is 3i, right? Hat. And let's say the magnitude of this vector is, let's say 2. But what would be the direction, guys? What would be the direction? Yes, this magnitude is 2, right? But this is in this direction. So what is this direction? If this is I hat,
Mine.
minus I hat. So this is minus 2i, right? Understood, guys? Understood?
Yes, sir.
So then the resultant of these two vectors would be how much? So this would be 3 minus 2 I hat, right? So it will be, the resultant would be in this direction, right? So this would be I hat. So this would be I. But let's say that I have this vector 3i, and then let's say I have this vector minus of 5i. So then my resultant would be in which direction? This direction, right? And that would be minus 2i. Understood?
Yes.
So in this case, I have to, so in this case, what I did was that my resultant was this, right? So my resultant was 3 minus 2 in this direction. In this case, my resultant was this one and this one. So this was 5 minus 3 and minus I, right? So whichever is the largest value, whichever is the greater value, so the sign will depend upon that. So let's say that in this case, A is greater, right? So my resultant would be how much? That would be A minus, is this clear?
Yes.
Right? Because this is in the negative direction, right? So similarly, we will use, so we have to remember this, right? And let's say, so this was the first thing that we should remember. Okay, and the second thing is that, let's say I have this vector A, I have this vector B, and I have, let's say, this vector. So the resultant would be how much? This would be vector addition of these three vectors. Understood? Any doubt in this, guys? Understood?
Yes, sir.
Okay, okay. So keeping only these two things in mind, remember that our phasor, right? So this is a vector. These are vectors, and whenever we combine these vectors, when we take the resultant, then we have to use the vector calculus, right? Keeping that in mind, let us understand about this LCR circuit. Okay, so we have this AC supply, and then we have this inductor, and then we have this capacitor, and then we have this resistor. So then we have this L, we have this C, and then we have this R supply. And this is, let's say, this is E, which is E naught sine omega. Right. So this is the overall circuit. Now, if I calculate the overall voltage, so this E for voltage would be L di by dt plus, for the capacitive circuit, what is the voltage? Yeah, these are in series, remember. So this is V1, V2, V3. So what is the voltage for the capacitive circuit? Do you guys remember? Voltage for the capacitive circuit. 1 by 1, 1 by V1. Okay, why 1 by 1? So Q by C, 1 by V2. No, 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 no. So we are not, okay, this we are not calculating the effective capacitance. We don't have two capacitors, right, Maya?
Yes, sir.
So these are not capacitors. So in series combination, you are right that this would be 1 by C1 plus 1 by C2. But the voltage is divided. So V would be always V1 plus V2 plus V3, right? Understood?
Yes, sir.
Okay. So, and the voltage of a capacitor is Q by C, right? Because your C is Q by V, right? So V would be Q by C. And In resistive circuit, what is the voltage? What is the voltage, guys? What is the voltage in resistive circuit? If I, let's say, if I give you this resistance R, and let's say some current is flowing in this circuit, what would be the voltage, guys? What would be this voltage? P would be IR, in
IR.
resistance, right? So this P is IR, right? And then P is V naught sine omega t, or let's write as E naught sine omega t, which is L di by dt plus this is u by c plus IR. Okay. So can I solve this equation? Remember, in the previous cases, we had a very simple equation. But Mariam got disconnected. So in the previous case, you see, we had a simple equation, right? And then we calculated the current in all the cases. So we calculated in the inductive circuit, this was my EMF. And then we integrated and then we calculated I. And this was the simplest one. In resistive circuit, C was simply IR. So then we calculated the current. And in the inductive circuit, E was LDI by dt. So then we had to integrate this to calculate the current. And for the case of this capacitive circuit, so this was my EMF, and then I had to differentiate to calculate the current, right? So now how can I solve this one? Yes, is there would can you imagine, Aisha? Will there be an easy method to solve this one? This equation? Yes. Right. So this is a very difficult equation. So if I want to solve this equation, then I'll have to, because this is Q, which means that I have to differentiate this equation further. So differentiating with respect to time. So then this would be E naught omega cos omega t. And this is L d square I by dt square. And this is 1 by C dq by dt is I. And then this is di by dt R. So this would be a second order equation to solve. So this is L d square I by dt square plus R di by dt plus I by C, and then you have this E naught omega cos omega t. So this equation is a second order. This is a second order differential equation. So simplifying this equation is tough. So then there would be the use of, then there comes the use of this phasor diagram. So that is why this phasor diagram is very useful, right? Because solving this is difficult. solving this is difficult, right? So then we will use this phasor diagram. Okay. So to use the phasor diagram, we have to remember that yes, Mayam, you got disconnected. So we only were discussing that how to solve this LCR circuit. So the analytical method is very complicated one. So we will use the phasor diagram to solve this one. So use of phasor diagram. Right. So to use the phasor diagram, we will assume that I have a current which is some I naught and sine omega t, sine omega t plus some phase difference. Okay. So this is my current. Got disconnected now. I am again got disconnected. So this is my current, right? Now, what do I know? I know three things. First thing I know that in resistive circuit, in resistive circuit, I and voltage, let's say VR, in same phase. This we know, right, Aisha? This we know, right? This is and in inductive circuit, current is lagging behind the, let's say, inductive circuit, right? By pi by 3, right? And in capacitive circuit, current is leading ahead of V, and this is capacitive. Why? Pi by 2. These are the things that we already know, right? Understood? Understood? Is this part clear? Here, Aisha. So I have this. Okay. So I have this current, right? I have this current which is. So I have this current which is I naught. So this is omega t plus pi, right? And this is my current. This is my current I naught. Okay. Now we know that the resistance would be, let me draw this as smaller. So this is my I, right? Now we know that voltage is with the same phase as in resistive circuit. So this is with the same phase, right? Let's say this is VR naught. Okay, understood? Is this clear? So V naught R. right? Now, for the case of the inductive circuit, so for the case of the inductive circuit, current is lagging behind 90, right? So the voltage would be ahead. So this is my V naught I, right? And similarly, my current is leading ahead of my voltage in the capacitive circuit, which means that this voltage is behind 90 by 2 with this current. So again in the 90 by 2 direction, right? So this is my V naught. This is my V naught. Is this part clear? Let me write it as, I'm writing this V naught as VR, right? And I'm writing, so these are small ones. And I'm writing V naught I as, that it is represented by L. So I will write it as L. And then this is VC. These are just notation. Remember that VR is I naught R, right? VL is I naught, right? And XL, and this VC is I naught X. These are the things that we already. Is this clear? Is this clear, Aisha? Okay, so what I will do is that, remember I was talking about these two vectors, right? So let's say that this is my VS and this is my VC, and this VC is greater than this VL. So my resultant would be this VC minus VL in this direction. So this is my VC minus VL. Okay, clear? So this is my VC minus VL. This is my VR. So then this would be my, let's say, this one, right? And then this one. So this would be my resultant vector. No. Is this part clear? Is this part clear, Aisha?
Yes.
Okay. So remember that this is omega t, right? V naught omega t. So this is my omega t. So this means that this would be 5. This is my 5. Okay. So this understanding this diagram is very important, right? So you know that how much is this? This is VC minus VL. I'm writing the magnitudes, and this is my VR. This is my VR. This is my VC minus. Okay. So my vector V would be, this would be VL or VR plus VC plus VL. Okay, this is my vector. And you can see that what is the angle between these two. Resultant of this one is VC minus VL. I have this graph, right? This is my VC minus VL. This is my VR. So how much would be this? How much would be V naught? This is the graph, right? So this is my VC minus VL in this direction, and this is my VR, right? So let me write it VR. This is V3, so this would be my V naught. So if I calculate the magnitude of V naught, this would be how much? Can you tell me how much would be the magnitude of V naught, Aisha? Yes. If you have any confusion, please tell. Root of absolutely right. So there would be square, right? So there would be square. So root of BC minus, I'm writing the magnitude, PL square, right? This is square, so this is, let's say, perpendicular square plus base square. So plus VR square. This is my resultant. Okay, and this is my phi angle, right? So my tan phi would be how much? Tan phi would be BC minus BS perpendicular upon base. So these are the things that we have. Okay, any confusion up to this point? Any confusion? I can explain it again if you want. So whenever you have any confusion, then please ask me. Okay, Aisha. Understood?
Yes.
Okay, so now let us find out the value of, because we want to find out the value of current, right? So let us use this first equation. So from equation first, E naught is EC minus VS square plus VR square, and let me, and what is the value of BC? I naught XC, right? So we will plug in all the values. So this is I naught XC, this is I naught XL, and square plus I naught and R square, right? Whole square. So this is I naught, I can take it outside, so this would be I naught square and XC minus XS whole square plus I naught square and then R square and then root over. So I naught square is common. I can take it outside of the root. So this would be XC minus XS square plus R square, and this is my V naught. If I take it in here, right, so this should give me some resistance, right? Resistance to overall current. And I call that quantity as impedance. So this is denoted by Z. right? And this is equal to xc minus xn square plus r square, where this z is called, this is called impedance. This is overall resistance. Any confusion in this, Aisha? Any doubt?
No, sir.
Right? So we have to just remember, we have to just remember that these are the voltages and these are the current in resistive, inductive, and capacitive circuit. And we have this current and resistance is in the same phase. And this inductance is, voltage is ahead of 90 degree, current is lagging. Current is lagging by 90. In capacitive circuit, current is ahead of 90, right? And then we take the resultant of these two, VL and VC vector. So this would be VC minus VL, right? So then we have this kind of graph, and then this would be the result. So when we take, when we use this parallelogram law, so we had this vector and we have this vector. So we make the parallelogram and then this would be the resultant vector, right? Okay, so please, if you have any question, please ask me. Other than that, please note it down, right? This LCR circuit is very important, and we will do some questions from this, and then this would be it. So that is why this phasor diagram is very important. Only two topics will be remaining there: resonance and what? Resonance and transformer. So those are all also the easier topics, so that in the next class those two topics will be done quickly, right? So this LCR circuit is very important. Okay, if face any doubt, so please ask me about that. Yes, whenever you want me to scroll down the screen, please, yes, whenever you want me to scroll down the screen, please tell me.
Done, sir. Done, sir.
Yeah, and in the previous class, I gave the homework to draw the graph. So did you make that graph, Aisha? Yes.
No, sir. I have actually my test going on. I'll do it.
Oh, okay. No, no, no problem. Yeah, but if you have any doubt, right? Whenever you have any doubt, in the revision also in any chapters that you are facing some doubt, please ask. Okay.
Yes, sir.
So remember, the graph is that you have uh, this current which is omega t plus phi, right? This is the current that you have, and then you have the same in the phase with the resistance, right? So you have this PR, and in 90 degree you have this L, and then you have this. So this is the graph, and then what you do is that you take this and the resultant would be this one. So PC minus right, and then you take the resultant of these two. So one and so then the resultant would be this, and this is omega t that you got. This is the graph, overall graph, right? And this is the phase difference between the current and the applied voltage. So this was all about this graph, right?
Yes, sir.
Yeah, should I scroll down?
Yes.
Yes, noted.
Yes, sir.
Okay, whenever you have noted it down, please tell. Okay, Daisha.
Yes, sir.
Okay, so yeah, and then the from the second equation, what we can say from second equation. From second equation, we have tan phi equal to PC minus S phi VR, right? And remember, this phi is what? Phase difference, right? So then this tan phi would be VC. What is VC? Uh, Aisha, what is VC?
We not case.
I naught XC, right? So I naught XC minus VL is I naught XL divided by I naught R. So then I naught is taken outside, and then this would be XC minus XL by I naught R. So I naught cancels, and tan phi is XC minus XL by R. So phase difference phi is tan inverse, and XC minus XL divided by R. So this is phase. And XC we already know that is 1 pi omega C. XL we know that is omega. So please note down this part. Whenever you have noted it down, please tell.
So,
Good. So we'll stop at here, right? And you have a class assessment. So please log into your Learnivio account, and please, whenever you leave, you please log into the Learnivio account and please take that test. Okay, Aisha.
yes, sir.
Okay, so see you guys. See you on Tuesday, right? Allah Hafiz, Aisha. And if you feel that you want to discuss a doubt, so we can arrange some extra classes also.